So now the concept we are going to learn is postulates of Bohr's atomic model. Previous concept we will come to know that inside the structure of atom, nucleus we come to know that through Rutherford, and it having positive charge and the electrons revolving around the nucleus. But there is some limitations of this Rutherford's atomic model that he cannot explain the stability of atom as well as the spectrum emitted by an atom. So next model, that is Niels Bohr's atomic model, is also called as, he explains some hypothesis by using Planck's quantum theory. So he explained the hypothesis of Bohr's atomic model using Planck's atomic model, Planck's quantum theory. So what Planck's quantum theory explains is, energy is liberated in the form of or transferred in the form of small energy packets called quanta or quantum. So he used this concept to explain the structure of atom. Okay, now what are the limitations of Rutherford atomic model? That is stability of atom as well as the spectrum. So he has taken the first concept, the first limitation of Bohr's atomic model become postulate of Bohr's atomic model. First one, what is that is, electrons are revolving around the nucleus in circular orbits, but in this is specified a one more special quantity that is called stationary orbits. Means, if according to Bohr's atomic model, electrons revolve around the nucleus, they have to lose their energy. So to overcome that one, he explained that electrons are revolving in circular orbits called stationary orbits or stationary shells. So these shells are named as K shell, L shell, M shell or N shell. So what is the difference is, an electron is revolving in these orbits, neither emits nor absorbs energy. So there is no loss of energy, so that the atom becomes stable. And we can immediately get it out that. So whatever it may be, if the electron or a person or any object is revolving or rotating in circular path or any path, has to lose its energy. It is not possible without losing of energy we can make motion. So immediately he explained the second postulate as, it is not losing energy because the angular momentum of this revolving electron is equal to integral multiples of h by 2 pi. We know that any particle that is in circular motion should possess angular momentum. So that angular momentum that is possessed by a particle or electron is equals to integral multiples of h by 2 pi. So that is mvr is equals to nh by 2 pi, where n is equals to 1, 2, 3 and so on. Means here, if angular momentum is neither greater nor less than nh by 2 pi, if it is neither either less or greater, then it loses energy. But here, because of this condition, the electron revolving in this circular orbits not emitting, not losing its energy. Okay, so by using these two postulates, the Bohr has explained the stability of atom. And next question is what? Spectrum. According to this theory, electron is continuously revolving around the nucleus, so that it has to emit continuous energy. But the energy emitted by atom is always discrete. So for this, the Bohr has given a beautiful explanation that the energy levels of the stationary shells that are present around the nucleus are not continuous. They are discrete. So when an electron makes a transition from one orbit to another orbit, it emits or absorbs energy. For example, an electron is in ground state. If we give energy, it moves to the higher excited state by absorption energy. We get absorption spectrum. When the electron wants to come back to its ground state, it comes to ground state by emitting some energy. That is called what? Emission spectrum. If the energy levels are continuous, it emits same amount of energy. But here, according to Bohr's theory, the energy levels are discrete. So it is going to emit discrete spectrum. The energy that is emitted by electron or absorbed has been given by the energy difference between two levels is equals to what? Emission of radiation in terms of photon. Because we already discussed that this Bohr's postulate has been explained based on Planck's quantum theory. So the energy is emitted in the form of photons.